We're here on the shore of Lake Superior in northern Minnesota. Lake Superior is the largest freshwater lake in the world by surface area at nearly 32,000 square miles and has a volume of nearly 3,000 cubic miles of water in it. That's 3 quadrillion gallons of water, 3 times 10 to the 12th gallons of water. Air temperature today, 18 degrees below zero. You can see that even though the temperature has been below freezing for the last few months here in Minnesota, the lake isn't frozen yet. Why would that be? One of the properties at work here is the fact that water has a very high specific heat compared to other materials. In simpler terms, water will be able to absorb quite a bit of heat without its temperature changing all that much. It takes a long time for this lake water to lose its heat and drop below the freezing point. There's so much water in Lake Superior that it can absorb so much heat from the earth and the sun during the summer months that it rarely freezes over completely before the long winter releases its grip on the region. Water has some very unique properties that allow life as we know it on this planet to exist. One of those is that's the only compound on Earth that exists in a liquid, solid, and gaseous state at the same time. An example of that is right here at this lake. Look out! What do you see happening? That very cool effect going on is what some call sea smoke, more aptly called lake smoke in this case, but of course it's really not smoke at all. If we take the actual temperature of the water, we notice that it's just above freezing, just above 0 degrees Celsius or 32 degrees Fahrenheit. And that's a huge difference between the temperature of the water and the air above it. That's like the temperature difference between the hottest desert on Earth down to a cool New England fall day. Warm air can hold a lot more moisture than cold air can. The hotter water gets, the higher its vapor pressure. And in the case of here, we have the warmer water of Lake Superior compared to the cold air right above it, holding a lot more of that moisture in. So the much warmer air just above the surface of the water holds a lot of moisture. As it rises, it cools down very quickly, and the colder air cannot hold as much water, so the water vapor will condense into small droplets very quickly and form a cloud. Actually, the same kind of effect as my breath condensing in the air. I said earlier there are 3 quadrillion gallons of water in Lake Superior. Let me throw another number out here for you. There are more molecules of water in this beaker than there are drops of water, not just in Lake Superior, but in all the rivers, lakes, and oceans of the world. That's how small atoms and molecules are.